Hey there, everyone. This is the beginning of the last lecture we did, which is our actual introduction to Max MSP. That class took place on February 25th. So what you're going to see is much of the lecture, and then at the end, somehow the video got cut off. And so if you skip to the end, I'm going to pick it up just a little bit where that video got cut off, just to kind of sum up the extra things we did at the end of the class. Anyway, here's the lecture. Okay, so we're back here in iMovie, and the thing that I had said last week, I'm just going to say it again, thank you for your patience, is that when I exported this file, this sound file was in this position right up against the film, and when I exported it, we didn't hear any sound. Well, that's because the peculiarity of iMovie is that we actually need to be, we need to move our sound down to where we have this little like double eighth note symbol. And now, if I export it, it'll be rock and roll. It'll be good to go. Okay, so I've said it twice. Okay, great. So yeah, let me know if you need any support with iMovie if you choose to use that in the labs for setting this stuff up. Are there any questions right now about the project due on Friday? No? Really? Okay, great. I hope it's going well. I hope it's going very well. That's all I have to say about that. So a couple classes ago, we started talking about MIDI. What does MIDI stand for again? Yeah, interface is in there, and musical is too. We gotta double check the order though, right? So musical's first, obviously. Almost. Huh? Musical instrument digital interface. There you go. Yes. That one does sound better, but alas. So when and how? Does anyone know a little bit of the history of MIDI to begin with? Anybody? No? MIDI came about in the mid-80s, the mid-1980s, because there were all these new devices coming onto the market and they couldn't speak to one another. I'm talking about synthesizers, drum machines, all kinds of fun technology, and they could not communicate between one another. So the big manufacturers got together, I'm talking like Roland and Korg, et cetera, they got together and they decided collectively to have a unified type of data and data transmission method. And so the earliest days of MIDI, don't forget it's just data. It's not actually sound. It's actually just bits of data. Devices could communicate over a wire that was a 5-pin connector. I don't have one in here right now. It doesn't matter because now we're living in the USB era. So 5-pin connectors do still exist, and some of the keyboards and things still do have them, and some people choose to use those, and it's basically a plug that has like 5 prongs inside of it. It's a little bit antiquated now because everything can be transmitted via USB. But remember what I said, how USB doesn't actually possess sound, it's just data. So MIDI 1.0, which is what we're kind of going to be talking about. There's more stuff about MIDI 2.0 we could talk about, but a lot of the devices we're using are still MIDI 1.0. It's basically sending like transmissions that are 8 bits of data. What does that mean, 8 bits of data? Well, it's a limited bit of information. 8 bits is not a lot at all. But even more so, one of the bits is taken up. You don't need to memorize this specifically, just check it out. This is just presentation time. One of those bits of the 8 bits is taken up with a 1 or a 0, telling it whether or not it's going to be a data message or a system message, like a system state message. Okay, fine, great. Here's my point. You basically have 7 bits to express basically musical quanta. So how many integers are available with 7 bits? A bit is a 0 or a 1. If you have 7 bits, that means you have 7 slots where you have a 0 or a 1. How many integers, how many numbers can you represent with those 7 bits? Not that many. Not as many as you might think. The calculation is simple. You take 2 and you raise it to the power of the number of bits you have. So 2 to the power of 7, what does that come out to? I already know the answer. Huh? 128. Yeah. Okay. Now, I'm still just throwing numbers around. What the heck does that even mean, bro? Okay, what that means is that when you're expressing musical information with this old method of data transmission, you're basically able to choose from 128 pitches and then 128 steps of velocity information. And then MIDI is using 16 channels. But okay, so velocity information? What the heck am I talking about? What does velocity mean in music? Yeah, it's how hard you're hitting the thing. Exactly. And then you think about the pitch information, that you have 128 pitches available. Well, middle C is 60. 60. Okay, so what's the D above middle C? Not 61, 62. Wait a minute. Let's review that. Envision this with me. Middle C is 60. I'm gonna do this. We're gonna hop into the max land. We're gonna go over here. I'm gonna open up a new max thing to help us visualize this. Because it's a whole step, right? So if I want to visualize this with a big old keyboard here. Don't worry, I'm going to explain everything I'm doing. This is just real talk right now. Okay, so if I pretend this is middle C, I'm visualizing it right here. It's not putting any sound out. Of course not. It's not hooked up to anything. But if that's 60, then this would be 61. And this would be 60. I'm sorry, 62. And this would be 63, 64, 65, etc. And then going down, 60, 59, right? 58, etc. Pretty straightforward. Okay. Makes sense? Now, we've slowly been talking about affordances a little bit in this class. We've grazed the topic. What do I mean by affordances? I'm going to post some extra reading that is supplemental, that is highly suggested. I know you might have a lot on your plate right now, but I'm going to post that reading tonight. It's actually an excerpt from another book about this idea of affordances. But anyone want to take a stab at it? Affordances. How much you can do. How much you can do. Keep going with this. How much you could do. Huh? Like an exception? No, but think about how the ideas of rules are formed. What you can do with limited space, that's interesting. Yes, we're on the right track. Wait, I heard something else. What you can and can't do, yes. So think about MuseScore. Think about MuseScore in your mind. Envision it. And then think about the graphic scores that we looked at the beginning of our semester. Some were like crazy drawings, right? And some were like grids and all kinds of interesting data that is supposed to communicate something to you. MuseScore doesn't allow you to make those types of scores very easily. It's not an affordance. Furthermore, the types of scores that you can make with MuseScore tend to be tempo bound, right? They need a tempo. They really like a key. They like to be using these staves. And while it does seem like there's a lot of options in MuseScore, you're still limited to these conventions of common practice Western classical music. Whereas if you wanted to do something that was a little weird and a little strange, MuseScore doesn't have an affordance for that. And actually, it's going to end up hemming you into an idea of what music notation should be. Wait, did you ever think about how the technology is coloring your idea about what the goal or the object is? I know we talk about this sometimes with like social media algorithms and things kind of can narrow your view about what you're seeing on certain services, right? That's a sort of affordance, I suppose. What we have to be careful of is presuming that what MuseScore can do is the be-all, end-all of the larger technology of notation. I'm going to say that again. We have to be careful of assuming that what MuseScore can do is the be-all, end-all of musical notation and conveying musical ideas. It's only one type. So some things can enlarge our view about what we can do, and some things can narrow our view about what the available options are. If you haven't thought about this ever, that's cool. I hope this kind of troubles the waters for you a little bit in terms of what you're interfacing with. And that's not to knock MuseScore. That's to say, like, MuseScore was created for a very specific purpose and yada yada. But I don't want to pretend that like those are the boundaries of musical notation, right? Even though I am grading you on speaking in those conventions and using those ideas, right? So when you think about it, this type of MIDI language is a different type of musical language that's expressing a similar thing, but it's expressed with integers and numbers rather than, how do I say this, abstractions on the page. Okay, back to my original question. What are some affordances and maybe limitations viewing MIDI with these integers? Because it might seem like, okay, we have 128. That seems like a pretty big range, right? But can we imagine some limitations there? Okay, yes, yeah. Like what? Huh?
Oh, sorry, I didn't know you were still reading. I don't know.
No? Okay.
I feel like, I don't know. Well, I was thinking about limitations on pitch because, like, if you're talking, like, only 128 pitches, there are musical instruments that can go more than that, or higher, lower, whatever.
Okay.
And we're always thinking also, I was thinking, like, microtonal.
You've got it. Yes, yes, you nailed it. Okay, exactly. No, exactly. So, or if you've played trombone or played cello or any of those instruments, or you've ever used your voice to sing, you know that there is this larger, like what some people call full chromaticism, where all of the pitches, all the available frequencies are available, right? Within human hearing, roughly. Some instruments can't go that low, and some voices and instruments can't go to 20K hertz. But nonetheless, everything in between is representable. But with 128 integers available, you don't get the in-between stuff, unfortunately. That seems like a limitation that if you're not aware of can hem in your view. Okay, what about velocity? 128 steps might seem like a lot for velocity, but we lose resolution on how specific those velocities can be expressed, right? Now, wait a minute. What velocities do we have available, velocities, in Western classical music? Think about MuseScore. Volumes, dynamics. How many do we practically have, though? Maybe about 8. Okay, so we have like piano, mezzo forte, forte. Those are very practical. Then we could say pianissimo on the extremes, and then fortissimo. Okay, and then I guess we could do like triple P or triple F and keep going with that. But past triple P and past triple F, what is it really communicating? So that resolution is even less when you think about classical scores. Now, there's a solution to this. MIDI 2.0 has many more integers available to represent these finer points of velocity. But we're going to work with the 128 right now for our MIDI stuff. Okay, so I brought a couple toys today just to kind of play around with a little bit with some MIDI stuff. We talked about MIDI controllers last time. I have another MIDI controller right here. I just love how bizarre it is. I have a little MIDI controller here. If you've ever seen it online, it's a little Playtronica. And what we're going to do is we're going to go into Max. And if you don't have Max on your computer, that's okay. Follow along. This video will be uploaded for reference. Let me get rid of this keyboard here. So what is, all that being said about MIDI, what is Max? Well, we talked about how it's a graphical programming language that's aimed at artists and musicians. And so you don't need to know like text coding. If you know text coding, great. And if you know JavaScript, great. There's actually ways you can use JavaScript more or less natively in Max. But let's make a metronome. And if you have it, follow along with me. If you don't, I encourage you to take notes. So Max is object-oriented. In Max, we create objects. And I have a blank palette right now. You can find objects up in this corner. Object, message, comment. These are, I know that one says object, but they're all objects. Toggle, buttons, etc. I'm going to be using some keyboard shortcuts because that's how I like to roll. And I'm going to hit T for toggle. And then I'm going to make it bigger. Okay, so I made a thing. I hit T for toggle, and then I made it bigger. Great. What does it do? Well, for me to interface with this, to interact with it, I have to lock the patcher. That means down here, there's a little lock. You have to hit that. If you want to be a cool cat, you can hold down Command on a Mac and click anywhere that's not an object, and it'll lock it or unlock it. When the patcher is unlocked, that's in modify mode. That is saying we're going to make changes to these things, we're going to move them around, we're going to add things, connect them, etc. When it's locked, that's like you're interacting with it now. Okay, so I'm locked, and I press this, and it does something. But what? Who knows? Okay, well, I have an idea. Let's create a thing called a bang. Now, bang is very specific Max MSP coding language. Max was like my first kind of language that I learned to code with. And when I would talk to people about like JavaScript and other things, I'd be like, oh yeah, send a bang. And they'd be like, what? Do a what? And it's a very specific Max, and Pure Data is an open source version, a kind of Max, and actually a later but earlier yada yada version of this. And those are specific things. So if you go to a coding conference and you're talking about bangs, they're just going to look at you like, what the heck are you talking about? Okay, well, this doesn't really mean much yet. But I'm going to make an object called metronome. How did I do that? What I did was, let me delete it. What I did was I went up here to object, and it gave me a little text prompt right here. I know it's a little small, but it gave me a little text prompt. I'll make it bigger. Boom. Here's the zoom. And in this text prompt, I can put an object name. Now, you may not know all the object names. If you put any letter, it'll start helping you and giving you a bunch of objects that you can put in there. So I'm going to put Metro. Now, some of the object names are intuitive, and some of them are a little obscure, right? Don't worry. For the assignments that you will have for Max, which you won't have one immediately, I don't think. No, probably not. But I will help you. I will supply the names of the objects that I want you to be using. You're also free to explore them on your own. But Metro is a metronome object. Okay, great. But let's do this. I'm going to click on this guy, and I'm back at my text prompt, space. Now check this out. I know it's a little hard to see, but it says arguments, interval, number. It's asking us for the rate of the metronome to be sending bangs. And it's in milliseconds. I'm so sorry. It's in milliseconds. So we're going to do 1,000 milliseconds, which comes out to 60 BPM. Okay, great. Now we got to connect them. Now this is where Max, I don't know, it tickles my brain as a guitarist, bassist, music tech person, because like you're literally connecting objects with cables. How did I do that? Let's do it again. I'm gonna disconnect them. So what I did was I clicked on the outlet. Inlets are on the top, outlets are on the bottom, always. Amen, amen, I say to you. Outlets on the bottom, inlets on the top. So what I'm doing is I'm going from this one, and I'm clicking and dragging to this input. Now, when you hover over one of the inlets or outlets, it tells you something. This one says output 1 or 0 when toggle is set. What does that mean, 1 or 0? On or off? Yes, which one's on? The 1, yes, okay, and the off is 0. Okay, clearly, just being thorough. Okay, good. So when the toggle is set, it's gonna send a 1 or a 0. Okay, great. Now, this inlet is waiting for a message that says start or stop metronome. It wants a 0 or a 1. So I'm going to plug it in. Boom. Now, if I turn it on, if I lock the patch and turn it on, it's working. But we don't see that. Because we need to connect the metronome to the bang. And this one says output ticks of metronome, right? Output the ticks of the metronome. And then here it is cause indicator to flash and bang output. So I connect it, boom, it's connected, turn it on, haha, it lives, it works. So the thing that's neat about Max is that we're connecting objects that do things. And we're thinking in a linear way about how objects are interacting. Okay, neat. Well, I made a metronome. Cool, great job. So let's make an instrument. Let's make something a little more interesting, shall we? And don't worry, we're gonna get back to this MIDI business. What do I wanna do first? Yeah, we'll do this one first. Okay, so I'm gonna make a thing called a K-slider. K-slider object. And I press N, that's the keyboard shortcut to bring up the prompt, K-slider, boom. And I can Command D and just duplicate them and make a billion of them, whatever. And so I made it a little bigger by just like a window, dragging on the edges of it. And this is the object I had before that we were talking about, the keyboard. Now, it obviously doesn't make any sound. So let's make it make sound. Let's do it. But wait a minute. We need some stuff first. Because remember that what I haven't told you is this guy is going to output MIDI information, MIDI data. But MIDI is not sound. So I need to think about the end of the signal chain. And at the end of the signal chain, I need a thing called an easy DAC, easy DAC. I'll make it bigger. What's a DAC? Yeah? Close. That would seem intuitive. That seems okay, but what's the opposite of digital? Analog. Yes, it's digital to analog converter. Yeah, right. And so, because remember, the digital data, the information is just beep, beep, boop, boop. It's just a bunch of information inside the computer. To actually be heard as sound, it has to go to this analog format, right? And so what this is going to do is it's going to take data and make it analog. I'm going to make a meter. I'm going to make a thing called live.gain with the tilde Swinton. And I'll make it a little bigger. It's hard to see because I have this black background going on. Let me change this, be a little more obvious. I'm gonna change this. If I use Lua, it's a bit easier to see. I know it's blinding. I know, I'm sorry. Just for a minute. So I want you to be able to see this. This is an output meter. This is a volume. I made a volume. I did a volume. Hooray! Can you guess what I need to do? I need to connect the volume to the output. I go down here. It says signal, scaled signal channel 1 goes to audio out channel 1. Boom. This one, I'm going fast, but I want you to see my process. Channel 2 goes to audio 2. It's in stereo, hooray. Now, wait a minute. These cables look different, don't they? I'm going to go back to the darker mode. It's a little easier to see now. I think we get the idea. These cables were, the ones before were gray, right? And these ones look like some kind of exotic snake. I don't know. Don't touch it. That's because Max is helping us by telling us this is a digital audio cable. This is sending digital audio information. Actual sound. Pretty nifty. Okay, great. Now, let's make a sine wave generator. It's called cycle with a tilde. Yep. And what we need to do is we need to send information to this. Now, wait a minute. Let me back up. Back it up. Hold on. What does this actually output? Well, in answering that question, I'm going to introduce you to another object. There's a thing called an integer object. You can just press I, or you can find it up here, and I think it calls it a numbers. Yeah, numbers, and there it is. But the I is for integer. Okay. And it just exists. Hooray. I'm going to output this one. This one reads, outputs key value changed or received. I'm going to plug it in there. And now, with the patcher locked, I'm going to interact with the keyboard. Oh, it's changing the number. Because now it's sending out the MIDI pitch information. I said to you, middle C is 60. There it is. Proof positive. It's 60. Okay. How does the K slider handle velocity? Well, by default, the velocity is determined by the mouse height on the key. So I'm going to make another integer. I'm going to connect the velocity output. And then notice, based on where I click, the velocity gets higher. At the tippity top is 127. At the very bottom is 0. Wait a minute, I thought we had 128 values. 0 is one of the values. Does anyone know the name for this in coding land, in computer land? It's called zero indexed. It's zero indexed. If anyone's ever played around with like 12-tone rows or set theory in music, it's similarly zero indexed most often. Okay, so great. So we can see that this is spitting out information. Cool. The sine wave generator isn't going to care too much about my dynamics, my velocity, but I'm going to send it this information. Now, I need another object first, because if I send this, take a look, zoom in, more. Doesn't really help. Cycle is looking for frequency. Is MIDI frequency? It's just an integer that represents a pitch. So how are we going to translate the MIDI integer into a frequency? Brutal. Well, you could look up a whole thing online and do that. Luckily, Max already has it. Max, dude, check it out. It has MTOF. That is MIDI to frequency. So I'm going to send that into that, and then let's make another, actually, not an integer. What is it called in computer land? Anyone know already? It's okay if you don't. Anyone know already when you use a decimal? Because they don't call it decimal. Huh? No? A float. There it is, a float. Yes, and we have a float object. Boom. By hitting F, we need a float. The float is standing for floating point, which is the dot, because in the early days when you had limited computer memory, you actually had to do a little bit of black magic with the memory to get it to have decimal values. And so that's held over, and we still call it a float. But it's a decimal. Great. Okay, plug it in. Boom. Nope, I don't need that. Go away. And so now, when I press one of these, let me extend this. Great. Now, it's converting my MIDI information into a frequency float. Super nifty. Hooray. Cool, man. Okay, now let's plug it in. Keep plugging it in. I know that's working. I'm going to plug this into cycle. Let's see. And by the way, no, we'll figure that out together. We'll do that together. I'm going to lower the volume so I don't break anything. And I want to set this to 0. And then I'm going to plug cycle. This is output. Boom. Output 1. And then output. It's behind my face. Output 2. Now, the other thing I didn't do is I need to send the audio to the Crestron. So audio, MIDI setup, Crestron. Hope it works today. And then in Max, I need to go to audio status and make sure our, that's fine. But the output will be Crestron. Should work. Should cooperate. Let's find out. Give me a second. What I don't like is, there it is. Hello, now we're talking. Lower the volume so I don't go crazy. There it is. Okay, great. It lives. How neat. Don't worry, it's gonna get weird. Don't worry, we're gonna get weird with it, dude. Okay, I'm gonna do a thing. Check this out. And by the way, I'm going through a lot of info. It's totally cool if you go back and review this video. I encourage you to go back and review this video. This won't be the only day I talk about these fundamentals. We're gonna do it kind of every time, because this is like a new language. Haha. I'm gonna make a thing called an attrui. Is attribute user interface. Do it again. True, and then it helps me. It helps me autofill. All right. Attrui. Plug in the attrui to this, and when I click on it with the patcher locked, it lets me change things about the keyboard. Super nifty. Super, super nifty. Okay. So the thing I want to change is I want to change. Where are you? Not input mode. Hello. Number of notes in the keyboard. Make it bigger. Make it go on into infinity. No, let's go. Let's just do our, we'll do our 88. Boom, okay, fine. Oh, no, I had the right one. Sorry, silly goose. Mode, display mode, touchscreen. And so, hey, I made a change to the keyboard. Notice that when I press down, the velocity is there, and when I take away my finger, it goes back to 0. It doesn't hold on to that velocity value, it assumes 0. When I take my finger away, is it gonna cooperate? Let's find out. Well, this part's cooperating, right? How would we kill the sound? Because notice how the sound is still going. The MIDI is still outputting integer 74 into the cycle object. So how could we tell cycle stop making sound? We could send it a message that says, 0. We could say, which for our purposes will be shut up in 0. Quiet you. Let's send it that. Okay, what did I do? I know, right? I made a message box, another object called a message box that says 0, and it's clickable. See how it's kind of clicking? It's clicking? Yeah. That means I'm sending that message into the other object, which means 0, which means stop. It really doesn't mean stop specifically in this context. It means that the frequency to output is 0, which is nothing. Okay, so cool. That makes sense. Hey, I wonder if we could, could I? No, I'll come back to that. I'm sorry. I'm getting ahead of myself. I'm having too much fun. Now I'm going to delete this, and now we're going to play around with this a little bit. Let's add an effect. So I'm going to use overdrive. Overdrive, yeah. Now, what if you were like, what does overdrive do? Here's an essential feature. This is true for every object. Every object in Max is you can double click it. I'm sorry, not double click it. You can right click it. That's 2 fingers on a Mac touchpad. And you go to Open Overdrive Help. And you click on that. And it gives you another patcher with a demonstration. And you can play around with that. It explains it, and it shows you like how to use it in an environment, and yada yada. So what does it say here? Okay, so we have, this is a sound file. That's like just, it's a sound file. And it's going into the overdrive object. Sound is output. So it might be hard to hear because I've turned it down a little bit. It is distorted. It's changing the level of distortion there. So what we need to do is send the cycle object, you guessed it, into the overdrive object. Send the overdrive object into, let me turn this bad boy down. Send the overdrive in stereo to the meter, and then let her rip. Well, it's not doing anything. Come on. Why is that? Because it needs an argument. So let's make a float, which is the decimal. How do I know it needs to be a float? Because right here, signal or float, drive factor. The drive factor. This is the knob on the tube screamer. It's the knob on the rat. Yeah, anyway, it's a guitar joke. So let's, little sine wave. It's distorting it so much that it sounds like a different type of wave. It's like messing it up so much. It's like no longer a sine wave, right? It sounds more like a square, which if you don't know what I'm talking about, it's okay. We'll talk about more later. So cool, that's an effect. As I lower it, notice I'm clicking and dragging to do that. Whoa. Whoa. Okay, so that's the idea, right? So great. Why did I delete my 0? That was silly. It was silly of me. Okay. And quiet you. Okay, that's fun. That's a little overdrive. Now, let's add something a little more elaborate. Let's do it. I'm going to delete these cables because I'm going to add another thing in the signal chain. By signal chain, I'm talking about, obviously, where the sound is going. Notice now, we've gone from our gray cables that are just math, it's just mathematics, to now we have the exotic snake of digital audio. This guy doesn't need to be digital audio. This guy is just float information. Okay, luckily, Max is developed by the same company that makes Ableton, so we have access to some of the Ableton stuff. So let's use the reverb device first. Ableton device reverb. It looks a lot different if you've used Ableton versus this. This looks a bit different. I'm going to open the help. It has a bunch of controls that I can use. Damping, pre-delay, decay, mix. There's even more. And we plug them into this input. Audio goes into that input. Then it goes out just like it normally would. Okay, let's try it. Well, those extra objects were attribute boxes. So I'm going to make a bunch of nothing. I'm going to make a bunch of attribute boxes. To save time in typing, I click on it, Command D, boom, 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 boom. I'll make 5 of them. And then I'm going to drag them to make them look cute, make them look nice and organized. Okay, they're organized. Now I'm going to plug in each one of them to the Ableton device. Hooray! Cool, man. And let's explore these. I didn't need 5. I'm thinking of there's another effect I'm thinking of today that has more parameters than it appears. 4, I have damping frequency, decay, dry wet, pre-delay. Okay. What the heck is going on here? So, what I want to say is, with the mix here, notice it said in the little menu dry wet mix. What is meant by dry wet? Huh? How much of the effect is there? And so what would be like full saturation would be fully wet, which would be 1.0. And fully dry would be 0.0. Now, I'm sorry to add another layer of complexity to this. Don't worry, I won't give you an assignment on this just yet. We're going to have another day to talk about this stuff more. But what I was going to say was, some things need a range of integers, which are whole numbers. And some things need float values between 0 and 1. Now, here's a weird trick question. Which of those ranges has more values? They can both go into infinity. The only limitation becomes how many integers can our computer represent and hold on to before completely crashing, right? Because you could just extend those decimals out forever and ever and ever and ever and ever. And similarly, you could keep going up into infinity with integers, right? So the difference becomes more of a memory allocation issue at an extreme level. We're not going to get that extreme. Don't worry about it, man. This kind of resolution where I'm just using to the tenths place is perfectly fine, even though I could actually do this. Now, notice, pretty nifty, depending on where you click in this area, with the patcher locked, here I'll lock it to show you, depending on where you click, you will affect a different range. And this is as far as Max wants us to go, actually. Because then it gets crazy. Okay, cool, great. Neat. Let's hear it. You can also play with decay and the damping. We'll talk about that later. The wet dry is what I care more about today. Audio goes in there. It has 2 outputs. Important. 2 outputs. Left channel goes in the left. Right channel, you guessed it, goes in the right channel. There it is. Okay, let's see what the heck we got here. Let's change this. Aha, I want this, I know. I want this, and I want that. And I want that. There it is. There's our reverb. Changing the decay level. Okay, you get the idea? Great. Let's add another effect. Let's do the Ableton device delay. The stereo delay. Yeah. Let's do it. We're getting weird. Okay. I'm going to do the same thing. I'm going to clone these. Boom. Come over here. I'm going to plug each one in. Boop. 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 There we go. And do you have one or two? Nope. Nope. Oh, you do. Left channel. This one says right channel. Right channel. Boom. Great. And let's check out what these parameters. There's more parameters than I have boxes for. Don't worry. If you set one of the boxes and then move to another one, it's just going to save that value. It's not going to delete it or anything. All of those are active. And these boxes are just giving us a window to interact with those parameters. So we definitely want dry wet. We already have it as mix. That's cool. Let's do delay times. And it's giving me these little dots here, so I'm going to extend it. It's a stereo delay, so I have a left channel and a right channel. Cool, man. Let's go in here and let's change this one to be ping pong mode. Enabled. Cool. Let's go over here and make this one be feedback. Yeah. It's going to get weird. Okay. And then let's plug it in. Okay, and I want more feedback. Let's take the reverb out and just isolate the delay. There it is. Ball, 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 ball. And then Okay, so already we have this pretty specific control over these things. Now you might be saying, Dr. Welty, well, why don't you just use Ableton? And I would say, Ableton's cool, Ableton's right on. What I would say is, we've only just begun, because I could then, I could automate, and I don't just mean like automating in a sequencer where I'm telling it certain commands. What if I wanted to randomly automate one of these values? There's an object for that. So here, let me kill this sound so I don't go crazy. So we've made basically, what have we made? What is this monster? It's a little MIDI keyboard that sends a command to a sine wave generator. That's the cycle. And then it has a string of effects, which are overdrive, Ableton's reverb, and Ableton's delay. And then it goes to digital audio output. So we're taking MIDI data, made it into digital audio, and then it's going to analog output. That's what I mean to say. Okay, cool, great. So I'll be the same. If I go over here, let's select all this and move it off to the side, and use this workspace here. Would you like it if it was lighter colored right now? Would it be easier to see? No? No? Shrug and destroy. Okay, here we go. Well, let's do a random number generator. Random, it literally is that. Open random help. And check this out. Random 40, bang, produces a random number. 31, 15, 18, 0, 10, 19, 24, 25, okay? Hey, computer question. Are random number generators actually random? No. No. And things like password generators can be hacked and stuff like that, of course. So it basically is a series of algorithmic steps to arrive at something that appears to us as a random number. But if you actually took a giant sample size, you would eventually find a pattern that's occurring. It would take a long time. It's pretty seemingly random. The closest thing we have to random is trying to anticipate an electron's position in a cloud. Anyway, that's as good as it gets for actual randomness. That still is not fully random, but appears random to us. Okay. Anyway, so I want this to make a random number. Let's just test it out. Let's use 100. And what I'm going to do is I'm going to create a bang and then an integer. And every time I hit bang, it's going to make a number. Okay, neat, hooray. But dude, I need floats. Okay, fine. Put a little dot on there. Boom. Put a float. Extend it out. Let's see. What up? Now we have floats. Great. Okay. Why would this matter? Well, let's do random 1 point, boom. And then look, now we have float values between 0 and 1. Okay. Are you following? Are you thinking what I'm thinking? Yes. Let's plug one of these guys into, I don't know, dude, let's get funky. Let's put it into the delay. So when I change it, it's going to do that. Now, unfortunately, this delay does not have 2 inputs for me to use, tragically. So let's live with it. It'll be the same for the left and the right. Now, I'm going to automate this because I don't want to go over here and have to click it every time. Can you guess, based on what we talked about earlier, is there a way that I can send regularly timed messages? Yes. What was that object called? Metro. And at what rate should we change the delay? You want to do 1,000? 10,000. Split the difference. Let's do 5,000. Because I don't want to stay for 10 seconds and wait. 5 seconds is reasonable though, because also it's going to have an effect. I need a toggle to turn it on. Connect the toggle to the metro. Connect the metro to the bang. Okay, let's make sure it works. Now what we're doing is we're watching this value to make sure it changes, boom. And every 5 seconds, it's going to bang and send a new value. Yep, it works. It lives. Okay. Okay, let's speed this up. Integer, plug in the integer there. Okay. Again, not comparing softwares, but the reason I like Macs is because you have minute control over these things. You're not stuck with simply the affordances that the Ableton object made for you. As convenient as that is, that's very convenient. You got a little knob and you turn the knob and it does the thing. But this, I can literally send math into these things to make it do something unexpected. Can you plug a PS5 controller into this? Yes. It actually will accept that. Oh, it crashed. Oh, no. Wow. Brutal, bro. Yes. How odd. Probably because I'm recording. It doesn't crash on me when I'm using. So where the video got cut off, we ended playing around with this device on our video. But in the class, I went and made, um, well, another video just to demonstrate how Max MSP can host virtual studio technology inside of it. So what I have here is I have a similar format with a virtual keyboard that is on Macs, and I'm not making any sound right now, but same virtual keyboard, and I've set it up pretty much the same as this one. I just made this one bigger. But over here, what I'm doing is I'm sending the MIDI information that's pitch and velocity. You see the velocity changing here. It goes back to 0 only because I have touchscreen mode enabled. But it's going into an object called pack. I'll zoom in on it. Let's zoom in on it. Pack. And that's just combining those two integers together. And then it's going into an object called MIDI format, and that goes out to our VST. Well, what's VST? Well, if you missed it in the class, VST stands for Virtual Studio Technology. And it's, if you've ever been in a big recording studio, maybe you've seen like effect units that are, how do I describe them? They're like in a rack mount, and it'd be like a long strip with lights and buttons and stuff. You have like compressors and yada yada, whatnot, amplifiers, all kinds of stuff, right? These VSTs are virtual digital versions of those. And so what Max is doing here is it's hosting a synthesizer I have downloaded on this computer. We'll talk about how to get those things in class. I'm not going to do that in the video just yet, but OBXD, if I double click it, it opens up the synthesizer itself. Now this device is not part of Max. This is another separate thing. I encourage you to go look it up on Google, because the same company that makes the OBXD makes a whole bunch of other synthesizers. And you can download them and use them for free. If you're using them in a professional recording situation or VST3 applications, which we'll talk about later, then they want you to pay for a license. It's very inexpensive. And yeah, and that would be good because that supports a company that makes really cool stuff. But for our purposes in class and just as students, we can use the freeware version. It's fine. Anyway, what's happening is this little MIDI device here that I've made in Max is sending data. It's formatted for the synthesizer, and then it's going to go out to here. Let's see. I need to change some of my audio real fast. Let's do, oh, it should be fine. Great. Let's see if I'm using this cold, if it'll, there it is. That's the sound, that's not coming from Max, really, that's coming from the synthesizer. And so this little integer box here is just calling up presets. And I can play around with this. Now, I can get more control if I double click on this, and then I can actually mess with things in the synthesizer here, right? And we haven't really, we haven't gotten to synthesizers properly, but down the road, when you download some of these things, you are strongly encouraged to twiddle the knobs and play around with all these buttons and things. Anyway, so that was the other thing that's really cool about Max, and I don't have it with me right now, but in the class I set up a Playtronica device to basically, it basically measures if a circuit is being completed, and if so, it sends a particular MIDI pitch through the wire and then in here. So I was basically controlling that synthesizer with my Playtronica. I'll probably demonstrate in class again next time I see you. Anyway, that's all I have to say. That really got cut off at the end of the lecture. Anyway, I hope your projects are going well, and if you have any questions, you can email me or comment on this video, or I don't know. But I'll plan to see you next week. All right, stay cool. It's getting warm out there.